In Unit 12, Part 2, we're moving on to our second method for solving systems of linear equations. This is called the substitution method. So the substitution method is used to solve systems. You solve one equation for one variable, and then you substitute it into the other equation. So you're going to take the first equation or the second equation, solve it for one variable, take that expression, plug it into the second. So there's three steps that you're going to follow for this. The first step is to solve one of the equations for one of the variables. And I'll walk you through this on the examples. So once we've solved one of the equations for one variable, then the second step is to substitute that expression into the other equation and solve for the other variable. So for instance, you'll solve one equation for y, and then you'll plug it into the y of the second one and solve for x. Again, I know this is confusing right now, but I'll go through it. So once I've solved for the other variable in step 2, I can substitute the value from step 2 into either of the original equations and solve to find the value of the variable from step 1. So for instance, if I solve for y in step 1, then I'll solve for x in step 2, then I can plug back in the value for y in step 3. Again, a lot of words. I'll walk you through it as we go. So let's look at our first example. It says to solve each system of linear equations by substitution. So let's go through it step by step. The first step was to solve one of the equations for a variable. If you look, the second equation is already solved for y equals 2x minus 7. They've already solved for y, so I don't have to do anything there. They've solved the second one for y. So then my second step is to substitute that expression into the other equation. So since they've already solved this equation, I'm going to plug this in for y in the other equation. So y gets replaced with 2x minus 7, and then that equals 9. So if you look at this point, I only have x. Okay, I don't have any y's in my equation, only x's. So now I can solve this out. So I get 3x, I have to distribute. So I get minus 4x plus 14 equals 9. Then I just continue to solve for x. So 3x minus 4x is negative x. I can subtract 14 from both sides. I'll get negative x equals negative 5. I'm not done there because I want to solve for positive x, so I'm going to divide both sides by negative 1. Now I get x equals 5. So I have my x value there. Okay, step 1 was to solve one of the equations for a variable. I didn't really have to do that because they already solved y equals 2x. Step 2, I took that expression and plugged it in for the y in the other equation and solved for x. So my last step is to plug in this x value to either of the original equations to get my y value. So let's say I'm going to plug that into the first equation. I would replace x with 5 minus 2y equals 9, and then I just need to solve for y. So I can subtract 15 from both sides. I get negative 2y equals negative 6. I can then divide both sides by negative 2. I get y equals 3. Now, I said in the directions you can plug into either equation. So let's say I wanted to plug 5 in for x into the other equation. So 2 times 5 minus 7. I get y equals 10 minus 7, or y equals 3. So if you look, it doesn't matter which equation I plug into. Now, if you remember from part 1, our solution to systems of equations are going to be ordered pairs. So 5 is my x, 3 is my y. That's how I would write my answer. All right, make sure you get all that down because I'm going to erase it here in a second to give myself some more room. All right, let's look at number 2. I'm going to start my work over here on the left just so I have some more room. First step is to solve one of the equations for one of the variables. If you look at the top equation, it's already solved for x. Okay, this is solved for x. Sorry, solved for y. Okay, they already solved it for y. Y is by itself. So step 2 is to take that expression and plug it into the other equation. So I'm going to replace the y with x minus 4. So I substituted or replaced the y. I only have x in here. So now I can solve for x. So 2x plus x is 3x. add 4 to both sides. I get 3x equals 9. And divide by 3. I get x equals 3. Then my third step is to plug that into either equation. So let's say I plug it into the top equation. I get y equals, replace x with 3. 3 minus 4 is negative 1. I could plug it into the other equation if I wanted to and still get the same answer. So if you get the second equation, if I replace x with 3, and then solve for y, that'd be 6 plus y equals 5. Subtract 6 from both sides, and get y equals negative 1. So either way, y equals negative 1. Again, my answer needs to be an ordered pair. So my ordered pair is 3, negative 1. So that is my answer. Alright, if you look at the back side, now these are going to get a little bit harder because they are not already solved for variables. So on number 3, my first step is to solve one of the equations for one of the variables. So I'm going to solve the second one just because the x is already has a coefficient of 4. So I need to solve this for x, so I'm going to add 4y to both sides. And I get x equals 4y plus 19. So that's all I have to do for step 1. Now, if I wanted to, I could have solved the top one for y, or I could have solved them for, or solve the top one for x, the bottom one for y, whatever you want. You can solve whichever one for whichever variable you want. I just chose to do x. Okay, no matter what, you do the same thing. Second step is to plug that expression into the other equation. So I solved the bottom one, so I need to plug it into the top one. So I'm replacing x with 4y plus 19. And if you look at this point, I only have y, which is fine. I only want one variable. I need to distribute here, so that's 24y plus 114 plus y equals 4. So I'm going to add my y's together to get 25y plus 114 equals 4. I can subtract 114 on both sides. I get 25y equals 100, negative 100. Then to solve for y, I divide both sides by 25. So I get y equals negative 4.4. I just punch that in my calculator. Totally fine that I have a decimal. It's not a big deal at all. So then my last step is to take that y and plug it into either equation. So let's say I'm going to plug it into the bottom one. So I have x minus 4, and then I replace y with negative 4.4 equals 19. So that's x minus, or sorry, x plus, because I'm doing a negative times a negative. That's going to give me 17.6 equals 19. And then I can subtract 17.6 from both sides. When I do that subtraction, I wind up with 1.4. So remember that my answer is going to be an ordered pair. So I get 1.4, negative 4.4 as my coordinates. And that would be my answer. Looking at the last example, okay, my first step is to solve one of the equations for one of the variables. I'm going to solve the top one because I already see that x has a coefficient of 1. So I'm going to subtract 2y from both sides. I'll end up with x equals negative 2y plus 8. So that's my first step. Solve one of the equations for one of the variables. Second step is to take that expression and plug it into the other one. So on the second equation, I'll replace the x with negative 2y plus 8. And I have plus 2y equals 6. So I'm only in y's here. I distribute, and that gives me negative 6y plus 24 plus 2y equals 6. I'm combining my y's, and I get negative 4y plus 24 equals 6. Subtract 24 from both sides. And I would wind up with negative 4y equals negative 18. And then my last step is to divide both sides by negative 4. And I would get y equals 4.5, which is a decimal, and again, that's totally fine. My last step is then to plug 4.5 into either equation. So I'm going to plug it into the top equation. I'll have x plus 2, replace the y with 4.5, equals 8. 2 times 4.5 is 9. Subtract 9 on both sides. I'll get x equals -1. Again, my answer is an ordered pair, or my solution is an ordered pair, so that'd be -1, 4.5. Get on the diagram. I know this is probably pretty confusing. Make sure you ask any questions you have.